Hello student, here I will discuss some applications of time series analysis. Like we have also discussed earlier about the forecasting, that is economic forecasting, all sales forecasting, budgetary analysis, stock market analysis, process and quality control, inventory studies, workload projections, utility studies. Those can be done using time series analysis. Uh, Basically, we are going to discuss in this series of video about neural networks for time series forecasting. So in case of neural networks for time series forecasting, we need to discuss about data issues, network design, model selection and evaluation, and methodological issues. In case of neural network modeling issues, developing a neural network model for a time series forecasting implementation is not a trivial task. You need to adapt to the situations. Neural network modeling issues include the choice of network type and architecture, and the training algorithm, as well as model validation, evaluation, and selection. So these very important aspects in case of neural modeling to forecast any data or to study any time series. You need to choose a proper network type along with the architecture. You need to train the algorithm. You need to use a validation model to evaluate your algorithm, and also you need to select the proper algorithm to test the data. In case of data, there are various issues like major decisions on neural network forecaster must make include data preparation, data cleaning, data splitting, and input variable selection. Also, size of the sample is also a important factor in this scenario. A larger sample provides a better chance for neural networks to adequately capture the underlying data generating process. Also, in case of data splitting, according to Sutphill, forecasting analysis typically retain about 10% of the data as a holdout sample. So again, Granger suggests that at least 20% data should be held for evaluation. So it is very important what part of data you will take for evaluation or testing, like that. Time series data are difficult or impossible to split randomly because of the desire to keep the auto-correlation structure of the time series observations. So time series data are different or impossible to split randomly because of the desire to keep autocorrelation. You cannot directly split it like the other data because it has some autocorrelations among the data for the random variables. Data pre-processing, input data normalizations to create more uniform data to facilitate neural network learning, meet algorithm requirements, and avoid competition requirements. So you need to provide a good data pre-processing steps. Input data normalizations to create more uniform data so that you can facilitate neural network learning, meet algorithm requirements, and avoid competition problems. So next one is about network design. The most time series in most time series forecasting problems, one output mode is necessarily used for one step ahead forecasting. That is, one step ahead forecasting is used in case of neural network design in most of the cases. One output node can also be employed for multi-step ahead forecasting, in which case iterative forecasting mode must be used. So a neural network design where you can use the forecasting mode by using one output node employed in the neural network to create it as like multi-step forecasting. For multi-step forecasting, one may either use multiple output nodes or develop multiple neural networks each for one particular step forecasting. The selection of an NN model is typically done using the cross-validation process. So to select a proper neural network model, you need to properly validate the model. So you need to use or typically it is done by using cross validation process. The principle of parsimony must be applied. After a modeling process, the selected model must be evaluated using the well established evaluation matrix, comparing it to well accepted traditional models using true out of sample data, ensuring enough sample size in the out of sample data. So there are other methodological issues also involved in case of neural network deployment in time series analysis. Like many business and economic time series exhibits both seasonal and trend variations. And seasonality is a periodic and recurrent pattern caused by factors such as weather, holidays, liberating promotions, like that. So traditional analysis of time series are connected or concerned with modeling the autocorrelation structure of a time series and required the data to be stationary. Trend and seasonality in the time series violate the conditions of stationarity. So first we'll go through an example of neural network to discuss about forecasting financial and economic time series. Here you can see one algorithm where the step one describes about variable selection, and variable selection means what type of variables or how many variables we will select, and then step 2 is about data collection. Then in the step 3 you need to pre-process the data. You might be need to remove the noises, might be you need to remove the null values, or you need to add the missing values, or you need to suppose normalize the data. Something like those things need to be carried out in the pre-processing step so that it can be easily deployed in the neural network architecture for proper analysis. Then in the step 4 you need to go for training, testing and validation sets. Means you need to split the data for training, testing and validation. And neural network paradigms, number of hidden layers need to be chosen, number of hidden neurons need to be chosen, and also number of output neurons to be chosen. And along with that, transfer functions need to be created. In the step 6 you need to create the evaluation criteria upon which your model will be evaluated. And then in the 7th step, neural network training will be done. Number of training iterations, learning rate and momentum need to be confirmed. And then in the 8th step, that is implementation or testing of the training algorithm. So basically these are the steps like variable selection, decide whether to use both technical and fundamental or not, and you need to collect the data, handling missing and observations like dropped, assume to be same, averaging, etc. Data pre-processing, differences, logs and ratios or normalizations like that. Training, testing and validation sets using walk forward testing. Neural network paradigms, there is no magic formula for selecting number of hidden layers and neurons. You need to go for empirical way to find out the proper number of hidden layers. Nonlinear transfer functions are more appropriate. Sigmoids are commonly used. You need to go for evaluation criteria. In case of trading systems, the forecast would be converted into buy-sell signals. They are fed into a program to calculate some type of risk-adjusted return. In case of neural network training, network use a business in the business processing network use a gradient descent training algorithm which adjusts the weights. Number of training iterations should be fixed number of, or converge need to use convergence rules. Then you need to go for implementations. So here you can see work forward sliding windows testing routine. Like suppose this is the data, then you need to select this part is as training set, this part as testing set, and this part as this relation set. But in the next loop, or when the data is forwarded, or when the time forwards, then you need to go for the shifting. That is why this sliding window testing routine means your thing or your window of the data will change after some time, or in the next forward, next loop, or next iterations. So or next set of data. and in that way your window of training set, window of testing set and validation set will be same like this way, but the proportion should be same in its window. Again, one case study of stock prices of Intercontinental Bank Nigeria. To do that, neural networks for time series predictions need to be applied. Error correction neural network, raw input like closing prices, highest price, lowest price need to be taken. Then neural network for time series predictions. Time series may be discrete or continuous, so we need to go for at least one with the good one according to your scenario. The problem of predicting the future. There is a problem to predict the future. You cannot directly predict the exact future. You need to provide some assumption or a prediction range like that. Assume a generative model, so you need to go for a generative idea. Embedding at time t, that truncate the history to previous d samples. So then again you need to go for model development. Then you need to go for data preparation. Data is transformed to weekly data using average, since we are interested in making weekly predictions. The number of input is 4. Here you can see in this one input will be 4, and number of network has 2 hidden layers like this one, each layer having 4 neurons. The number of epochs used is 500, means 500 iterations will be done to finally find out the exact accuracy. Then you need to go for neuro computation. The weighted sums are calculated and passed through the activation functions. In our case, like function of W sum, weighted sum minus the target, where W sum is weighted sum of the inputs and T is the threshold or bias value. So for the activation function F, we use the sigmoid function in this project, means in this case study, at the hidden and the output layers. So you can, as per the results from this case study, you can find in the reference, this neural network is trained to forecast one period ahead. So for data 0.43870, the forecast is 0.32756. So error in forecast is 25%, so the accuracy is 75%. So for the next data, it will be forecast like this, so accuracy is increasing. The accuracy forecast can be improved further by training a network with more data. So you can go to the references. I'll upload these slides in Google Meet also, Google Classroom also, and also try to go through more literatures to verify this content. It does not directly rely upon whatever the slides is giving. Please go to the literatures existing in the research domain, and if you find difficulty, please let me know. And also if you want to add something or share something new, then also let me know. We'll discuss everything or resolve every doubt over Google Meet. Till then, thank you.